Yeah, welcome back, everybody. It's 3 o'clock now. So the next talk of this afternoon will be given by Dr. Shu-Ya Chen, and she's a postdoc fellow at the GPS Science and Applications Research Center of National Central University. And she's expert on this occultation data research. And I will let Dr. Chen to start her talk. Shu-Ya, please go ahead.
Okay. Thank you, Dr. Ye. Actually, I would like to update. I'm not a postdoc fellow. Actually, I'm a assistant researcher in the GPS ARC. And I also want to thank TSU for inviting me to give the presentation. Today, my talk is about the FORMOSAT 7 cosmic 2 radio occultation data in the troposphere and the application of GNSS R data in the numerical weather prediction. So here is my outline. In the beginning, I will just briefly introduce about what is the radio occultation technique. And in my talk, there will be two parts. The first one is about the analysis of the FORMOSAT 7 data quality in the troposphere. And the second part will be focused on the GNSS R data application for the numerical weather prediction. I will show some my previous study is about Antarctica cyclone, heavy rainfall event, typhoon or hurricane, and I will more focusing on the tropical cyclone genesis. Then final is the conclusion and the future work. So here is a movie to show the radio occultation technique. So we can see the ray passing through the atmosphere. Then it will show the band, and because the air density, then from the bending angle, we can derive the reflectivity and then the atmosphere temperature and the moisture. Then from this, we can see this movie is simulate FORMOSAT 7 data in 6-hour period. So we see the our data more locate in most of that locate over the tropical and the subtropical region. Then the data can cover over the continent and also over the ocean. So we know that over the ocean, the observation data are very rare and they are very valuable. So we can get our data to further improve our weather prediction. Then this one is collect the data from the first day of we receive the FORMOSAT 7 data in July until the end of 2020. This figure is provided by TACC. So we can see there are more than 2 million data available. And then also we can see the data amount is about 4,000 to 5,000 data per day. So since we have this abundance data available, so we would like to see how the data characteristic in the troposphere. So this work we have published in the remote sensing in this February. Then in this work, we using 6 months data for the comparison. And this one shows the data density during 1 month. And this one is the data from FORMOSAT 3 we only collect the data between 45 and negative 45 latitude, this region, to compare with Formosa 7. So we can see over the tropical region, there are a lot of there are more data available for the Formosa 7 than compared to the Formosa 3. The data are counted on 2.5 by 2.5 beams. So we can see there are about more than 40 to 50 data available on each beams. Then this one is shows the data penetration depth. We want to see how the data can penetrate to close to the surface. So we compare the one-day data from Formosa 3 and the Formosa 7, and we can see more red. It means the data can penetrate to closer to the surface. So we can see more red dot in the Formosa 7 compared to Formosa 3. And using 6 months data statistic, and we use a data interval by 500 meter interval. And from this histogram, we can see there are more data from the Formosa 3 is can penetrate to the 0.5 to 1.5 kilometer. And for the Formosa 7, most of the data can penetrate to the below 0.5 kilometer. So we calculate all the data below 1 kilometer. We can see the penetration depth rate for the Formosa 3 is about 40% to reach below 1 kilometer. And for Formosa 7, it is doubled to the more than 80% of the data amount can reach below to 1 kilometer. Then we get the 6 months data from October 2019 to March 2020, and we try to verify the Formosa 7 data compared with radio sound, and we also compare the data with other RO mission like Concept 5 from Korea and METAP RO sounding from FORMOSAT, and we also compare with other satellite retrievals and global analysis. And this figure shows the data pair on each day. So we can see there are a lot of data can be compared during these 6 months. So before the comparison between Formosa 7 and the other data set, the effect of the spatial temporal distance for the collocation is very essential. So we compare the data differences between the Formosa 7 and the other data set, and we can see the mean differences shows increasing with the spatial distance increase, no matter in the temperature or the vapor pressure. However, for the time departure, we can see the differences, the variation of the differences is insensitive to the temporal departure. So based on this result, we choose a collocated window with 3 hours and 100 kilometers for the data pair. So for the Formosa 7 verification, we have two kinds of spatial observations available. One is from the CWB provider, the drop sound observation. Then, and the other is the research vessel legend the experiment from NTU to provide the radio sound soundings. So to get this data, we can take these observations as the ground truth observation, because this data over the ocean is very useful. For example, here just shows one case. Here is the one RO sounding from FORMOSAT 7, and this one is one drop sound. And we pick these data pairs for the comparison because this one shows a small distance in between. They have about 50 kilometer spatial distance. So we can see the green line shows the temperature difference. We can see the temperature difference is very small. The larger difference is about 1 degree Celsius. And also the other one is to compare the FORMOSAT 7 and the data with the radio sound from the legend. Then it also shows consistent result with a small difference in temperature. So the previous two are the comparison over the ocean, and this one is we choosing 6 months radio sound data. Most of this data are located over the continent. Then we compare this data. The data among more than 10,000 data pairs. Then we can see the temperature. The mean difference in the temperature is also small. The maximum differences, mean differences, can be about less than 0.5 Celsius. And for the vapor pressure, the blue line it also shows less than 1 hectopascal in the mean difference at the lower troposphere. Also, for the standard deviation, it shows about 1.5 Celsius in temperature and less than about 2 hectopascal in vapor pressure. And here, please notice that there shows negative differences in the vapor pressure at the low troposphere when compared with radio sound. Then this one is we take the FORMOSAT 7 to become the true for the to verify the other data set. So we compare with MATLAB and concept file. It also shows temperature differences is about less than 0.5 Celsius, and vapor pressure is less than 2 hectopascal. But here shows positive differences. It's because we use different ground truth data for the verification. So in previous one, this one is using a FORMOSAT 7 minus radio sound, and this one is data set minus FORMOSAT 7. So it will be upside the difference pattern. However, the magnitude are comparable. And this one shows we also compare with the global analysis. So here shows the vertical average from surface to 200 hectopascal. And in the temperature, here shows the mean difference and the standard deviation. And this one is compared with ERA5 real analysis, and this one is compared to the UNCEP final analysis. This one is compared to the satellite retrieval. So we can see all of these show similar patterns with negative temperature and mean differences. And for the vapor pressure, it shows a consistent pattern when compared with the global analysis in like ERA5 and FNL. However, for the theta retrieval, it shows opposite pattern with negative mean differences. So it's because a dry bias of the water vapor retrieval from the new caps, which already found is because the absorption of the clouds in the infrared spectrum. So all the about this detail can be found in these two papers. So that's why it shows different behavior with the other data set. So from this data comparison, we know that the penetration depth is very encouraging. From the FORMOSAT 7 data, it can reach lower altitude about to 1 kilometer, about 80% for FORMOSAT 7 and about 40% for FORMOSAT 3. And all the comparison between FORMOSAT 7 profile and the other data set all exhibit consistent vertical variations. And from this study, it showed the statistic mean differences and standard deviation in the temperature are less than 0.5 Celsius and 1.5 Celsius for mean differences and standard deviation. And for the water vapor, it shows the deviation within 2 hectopascal in the lower troposphere. From this study, we're using the data derived on TACC, which using which is data processing the same as CDEC in UCAR. In Taiwan side, we also develop our own data processing system. It's called TROPS. Is Taiwan Radio Occultation Processing System. We have several groups involved. They are NCU, the GPS ARC in NCU and NSPO, TACC in CWB, and the NCKU. And we also did a similar comparison, but we get the same input from TACC and feed into the CHOPS 1D and get the weight product. And then we compare with radio sound concept and MATLAB, and here shows the mean differences and the standard deviation in vapor pressure and the temperature. All these patterns are very similar and comparable to what we shown before. Those we using the data from TACC. So after the data analysis, then the next part is about the data application. So how to put the observations into the numerical weather simulation. Better ways to using the data simulation. So we know the data simulation, the purpose of data simulation is to determine a best possible atmospheric state using observations and the short-range forecast. So we're using this technique to assess the data impact on the numerical weather prediction. Before introduce the case study, first I would like to show the result from ECMWF. These slides are provided by Dr. Sean Healy. He presented in ICGPSR 2020. He showed that the FORMOSAT 7 our data have been implemented in the ECMWF operational system. And please see the orange line. You can see before the using the FORMOSAT 7 data, the FSOI, the percentage is about 4%, and after assimilated the FORMOSAT 7, it significant increase to 10%. It means the data is very helpful for the weather prediction. And also the FORMOSAT 7 data are also implemented in both the US NSAP and the Taiwan CWB operational system in the later 2020. So this one I will in the beginning I will show some previous study to use like GNSS RO data and to assess the impact on the severe weather event. And because FORMOSAT 7 were launched in 2019, so for this case I using FORMOSAT 3. And in the end of this talk, I will show some preliminary result by using the FORMOSAT 7 data. So here just show we also investigated our data impact on an Antarctica cyclone. So we can see this one is the serial pressure from ECMWF analysis. So if we take this as a true, we can see here is a vortex, and there's a pressure law over here is because the geographic and make the gradient to have the pressure. Then this vortex take the lead, then keep developing. However, if we do not assimilate the our data, the law over near the coast, it will take the lead and keep the development. And with our data assimilation, we can see the vortex over the ocean. It can take the lead as let's show in the ECMWF analysis. So in this case, it also show with our data assimilation, the intensity will predict very well as the best check, like the red line and the black line. Black line is the best check, and red line is from the simulation with our data assimilation. Okay, so the second part is about the heavy rainfall event. Then from previous study, it also demonstrated that with our data assimilation, it can improve the cold pool over the South China Sea, and later on it can further improve the rainfall prediction over southern of Taiwan. Then we also investigated our data impact on the Northwestern Pacific typhoon event, and also on the Atlantic hurricanes. From this, the blue line is the result from with our data assimilation. So we can see the check error with our data assimilation. It shows smaller check error, and also the simulated check, the blue line is closer to the best check, the black line. Then for the hurricane call, it's we using an airborne radio occultation, and it also show a better prediction in the intensity. So here I would like to focus on the tropical cyclone genesis. And this result already published in June 2020. And why we do this work is because if we can have more time to prepare, like the early we know a cyclone will spin up, then we have more time. We have more time to have prepare for the disaster preparedness. Then, so we pick up 10 typhoon cases, and during 2008 to 2010, then we choose, for example, here is the genesis time for each typhoon. Then we pick up 5 days before for a starting time for the data assimilation. So for each case, we have 3 days data cycling data assimilation, and then we focus more than 2 days to see if a simulated vortex are genesis at this time or within 24 hours compared to this time. And then we take this as a successful simulation. So for these 10 cases, we can see with GPSR data assimilation, we can, it shows successful generate the cyclone genesis for, there are 7 cases. So it means the probability of the detection for the case with our data assimilation is 70%. And however, if we do not use our data assimilation, it will reduce to 30% only. So to further investigate how the data impact on the cyclone genesis, so we choose one typhoon case is Typhoon Nuri in 2008. Then in the beginning, we would like to see how the data impact when the owl sounding around this the precursor area. So we try to remove the owl sounding over this region. Then the result shows no cyclone genesis for this case. So from this, it's indicated that the owl data near the incipient stone are quite important for the prediction of cyclone genesis. Besides Typhoon Nuri, we also have 2 other cases and did a similar experiment and also show the same result. So for Typhoon Nuri, first we get the analysis, global analysis from NCEP and from ECMWF to be the initial condition for the work model. Then we can see after 48-hour focus, there's no cyclone genesis for both cases. Then after at a later time with the ECMWF initial condition, it can genesis a vortex. However, it's already 30 hours delay. So with our criteria, is indicated that both the cases, both these 2 cases are for to predict the genesis of Typhoon Nuri. If we assimilate our data for 3 days and then focus 48 hours, then we can see here shows the zero pressure. The contour is the zero pressure, and the color is the wind speed. then we can see this is the initial time, 24-hour focus, 48-hour focus. It's already form a closure zero pressure center. Then at 72 hours, it can see the a vortex over here. Without radio occultation data assimilation, after 72-hour focus, it still show no cyclogenesis over here. So this movie shows the simulation integrated cloud hydrometer from work model. So the left-hand side is without our data assimilation. The right-hand side is shows with our data assimilation. So from this, we can see the cloud start to spin up, and then to be a vortex over here for the typhoon Nuli. However, without our data assimilation, there's nothing over here. So we try to figure out how our data impact on the genesis. Then for the typhoon Nuli, then we pick up 6 degree by 6 degree boxes center from the stone. Then we get the differences with RO minus without RO data assimilation. The x-axis is the data assimilation period, time period, and the y-axis is the pressure. So we can see there are large differences in the lower troposphere. Here shows the contour is the moisture. So here shows with our data assimilation provide more moisture over the tropical over the lower troposphere. Then this more moisture will moistening of lower troposphere, then will induce convective instability, then produce vertical motion like the red color. Then mid-level vortex will, with the higher humidity, will formed over here. So from the cross-section of the vorticity and the relative humidity, we can see this one is from without RO, and this one is with RO data assimilation. So the contour line is the vorticity, and the color is the relative humidity. So we can see a large relative humidity near the surface at the low level, and with the our data assimilation, it can increase the moisture, and then induce the vortex in the lower in the mid level. How without our data assimilation, there's very weak and cannot continue develop. So from this result, it shows the possibility of detection of TC genesis 70% and 30% by assimilating with and without our data. And the assimilation of our data can significantly improve the analysis of vapor pressure over the tropical region, over tropical oceans, and which is critical for the prediction of tropical cyclogenesis. I didn't mention that in this study we also compare different RO forward operator, and the 70% detection is by using the non-local operator, which can consider the horizontal gradient of the atmosphere. So this one can much improve the analysis over the region with large atmosphere variations. So we already know the moisture information derived from our sounding in the lower troposphere, in the lower tropical troposphere, especially in the vicinity of the stone, is most variable. So here we try to assimilate the FORMOSAT 7 data to see the data impact on severe weather. So here is the Typhoon Huckabee. It happened in 2020. So here shows the satellite image. We can see the cyclone genesis over here. Then we use the same configuration as Typhoon Nuri, and then we here shows the serial pressure, and the color is the total precipitable water. It means the moisture. So we can see the with FORMOSAT 7 our data estimation, it can successfully simulate the cyclone genesis, the Typhoon Huckabee. However, without our data estimation, the serial pressure is is not intense, and this cannot reach the criteria for the for the cyclone genesis. So here shows the movie, and this one is without our data estimation. This one is with our data estimation. So you can see the vortex can keep continuing developing. However, for this one is gradually disappear at the later simulation. Another case is for the Typhoon Likima, is in 2019. In this case, we use a global model, which is MPES and model, and using a global GSI data simulation system. So we can see we assimilated the radial occultation bending angle from FORMOSAT 7. So the red line is the without data estimation, the check, simulated check, and the black line is the best check. Blue line is without our data estimation. So we can see without data estimation, it significantly improve the check forecast, very close to the best check. And also for both cases, the rapid intensification for the Typhoon Likima can be predicted very well, like this. So conclusion, from previous study, the information derived from our sounding in the lower troposphere, in the lower tropical troposphere, especially the moisture, is important for the weather prediction. And we also know that FORMOSAT 7 provide more and deeper penetration data over the tropical and subtropical region, which could be very useful for the weather prediction, especially over the near Taiwan. So from preliminary results show that the simulation with FORMOSAT 7 data can perform a significant positive impact on the simulations of Typhoon Huckabee and Typhoon Likima. And further investigation of the result and carry out more cases will be conducted in the future. So if someone are interested about more detail, I also list all the reference over here. Okay, thank you.
Dr. Chen, thank you so much for this very detailed presentation. And I would like to ask the invited audience to ask questions. You have any questions, please either unmute yourself or raise your hand. Well, while I'm waiting for questions, maybe I could ask you one or two questions.
Okay.
So you compare, you know, at the very beginning of your talk, you compare the cosmic 2 Fu-Wei Qihao data with other satellite observation, correct, right?
Yes.
And then you said that the temperature difference in the troposphere is always less than 0.5 to 1.5 centigrade.
Mm-hmm.
And is that good or bad?
I think it is good.
It's good.
But
Okay.
it still have some it still can be improved, I think.
So it's good. So I mean however, 1 degree error would make a lot of difference. Is that right? For the tropospheric
Yeah.
process. And another question is, of course, is that which one? I mean, you say you compare your data with others, and then finding a 1 centigrade error. Difference, which is small. On the other hand, one would still like to know: does that mean that your measurement, your data are the best, or what? How can we judge?
So because we don't know which one is really true, so that's why we get the data from radio sound, and because the radio sound is be taken as very true because the error is small, pretty small.
Mm-hmm.
Yeah, so that's why in the beginning we compare the FORMOSAT 7 with the radio sound, and the other compare with other our mission is just show the differences, but we cannot say which one is more correct.
So anyway, you're happy with with the accuracy of cosmic 2. The other thing is that you refer to the 70% versus 30%. Is that for the prediction of the typhoon tracks, or for the cyclone genesis that you mentioned later on?
70% is for the cyclone genesis prediction.
Okay. But that number came from what? From the cosmic 1 or from cosmic 2?
Cosmic 1.
For me,
because the case is during 2008 to 2010.
Right.
At that time, there's no FORMOSAT 7.
So that means FORMOSAT 7 will give you an even better accuracy.
We hope.
Will be 100%.
So that's what we need to find.
Okay, we will see, right? I mean,
Yeah.
after a while, we will see how successful you are. I hope that is better than 70%, of course.
Yeah.
All right, and of course, another thing is that you saw some, because in the second part of the talk, you actually demonstrating or showing the value of this data integration synthesizers. That's why you saw an example of the Atlantic cyclone. Of course, for FORMOSAT 7, you cannot do that, or can you?
Yeah, cannot. I cannot. So that's why we need more our data.
I mean, because you don't have to track over there anyway, on the polar region, high altitude region.
Yeah, we don't have that from, if we get only from FORMOSAT 7, but we still can get other our data from like Concept 5 and MATLAB.
Right. Very good. Do anyone have questions for Dr. Chen? I mean, this is almost one of the very few. I think that there are already a number of papers published on the FORMOSAT 7, and it's very good that this is a very detailed analysis, and I hope that you are going to have a lot of. You have I think I see that in your future work, you want to do a lot of things. Okay, if no questions, let me see. We would then end this this is the second talk here, and we'll thank Dr. Chen, Shu-Ya Chen. Once again, thank you so much, Dr. Chen.
Thank you
For making the time and give this talk.